Welcome to Devo's Toolkit, the channel where we keep applications in Kubernetes even when they're actively trying to run away from it. Backstage is great, or not, depending on how you look at it. In any case, the important thing to note is that the only thing we are getting is source code. Since it is written in TypeScript, we can run it by executing yarn, this or that, or node, this and something else. Well, that is probably okay, more or less, while developing it. It is silly when running it in production, or anywhere else, other than your laptops. Because, come here, here's the secret. It's not 1999 anymore. Today we package almost everything into container images, and from there on we might be running it in Docker while I scream at you trying to explain why Docker is not a good idea for anything that should run in production, right? You know that. More likely you're running your applications in Kubernetes or as Azure Container Apps or through Google Cloud Run or anywhere else. What matters is that OCI images are the standard, no matter whether we run something as containers or anything else. Unfortunately, and there's a lot of unfortunately with Backstage, Backstage does not provide neither final nor even base container images. Similarly, there are no Helm charts or any other official way of running it. There is not even a base we can customize. There is only source code and a Docker file, which is, in my opinion, not the one we should be using. Or to be more precise, none of those things are provided by the project itself. You need to look elsewhere. So, if we want to run Backstage, we might need to create ourselves a Docker file and Kubernetes manifests and whatever else we might need. That's what we will explore today. We will see how to package Backstage into OCI images and how to run it with Docker. From there on, we'll explore how to run it in Kubernetes by defining anything we need as a Helm chart. Finally, we'll see how to package and publish images and charts through CI workflows so that everything is automated and we can focus on writing Backstage code or configuring it while knowing that all the operations are executed every time we push changes to Git. Now, before we continue, let me stress that I will assume you have basic knowledge how Backstage works. If that's not the case, please watch that video over there. With that out of the way, let's get started with OCI images defined through Dockerfile. Here's a Docker file I am using to define all the stages required to build a container image with Backstage. That Docker file is very similar to what is presented in the Backstage documentation, which, by the way, is not available in the project repo, or if it is, there is no link to it in the documentation. I cannot explain why that is so without being vulgar. I might not resist the urge later, but for now, I will contain myself. We just started, so there's still time for me to go crazy. Anyway, that Docker file uses multi-stage builds where each stage starts with a from statement and only the last one is kept as the final image. That way we can do whatever needs to be done without carrying over leftovers from activities that should not be available in the final image. The first stage copies all the files we'll need for the second stage that essentially installs the dependencies and builds packages. The last stage is where the actual resources we'll need are built and the final image is created. The only thing that matters here are the first few lines in the first stage. Over there we are setting the work directory, workdir to app, and defining the source variable that points to the local source code. That's where the cloned Backstage repo is. I prefer never changing it in any form or way so that I can always pull the latest version without running into conflicts between my files and the Backstage repo. That's yet another Backstage silliness that forced me to have a repo with my configs and plugins separated from the original Backstage repo. I explained in more detail that strategy in that video over there. There we go. Right? If you haven't seen it already, you might want to pause this video and watch that one first because it covers some basics. Anyways, the two copy instructions are copying packages from local file system to the container image, and the rest of that Docker file are mostly apt-get and yarn commands. Now, I won't go into more details since I'm assuming that you are familiar with building container images with Docker file. I'll also skip explaining Backstage specific steps in that Docker file since it is, how to put it, it's madness. that reflects the complexities of Backstage itself. What matters is that Backstage will run with 3 config files. There is appconfig YAML, which is essentially the same configuration file we're using while developing and running Backstage locally. The other 2 are custom and are used to provide additional values or override those that already exist but should be different in production. So let's take a look at them, starting with appconfig ingress. That's a simple one. It overrides base URL for the front end and the back end with the environment variable. That way we don't have to worry what the host will be while building the image, since we can define it in manifest that will use that image. The appconfig production is simple as well. Over there we are telling Backstage that we would like to use a real instead of the in-memory database used by default. While in-memory database is useful when running it locally, especially while developing, real Backstage, I mean real in quotes, usage needs a real Postgres database. Actually, I don't know why I'm quoting, so it's real in both cases. Just as Ingress, database settings are using environment variables, which we'll set up later. Besides the database, we're adding GitHub as one of the catalog providers. It will get catalogs from the main branch from any of the repositories in the organization. Similarly, it will also retrieve templates from any of the repositories. Now, before we continue, let me be clear that this is not necessarily the full production setup. That would depend on your needs, so you might want to modify those configuration files by, for example, adding authentication or whatever else you might need. If there is enough interest, I can create another video with everything I believe we should do to run Backstage in production. Right now, we are mostly focused on all the steps we might perform to get to production in one form or another. So, okay, let's get back to the task at hand and build the image. Building Backstage image might take anything from a few seconds to infinity, eternity. There's a lot going on there. Backstage is based on Node.js, meaning that half of the internet worth of libraries need to be downloaded. It's based on Node image but needs to install Python and a few other dependencies with apt-get and so on and so forth. We could speed it up by performing some actions without Docker so that some commands are executed faster, since that would give us some effective caching or more effective caching and a few other boosts. Still, even though multi-stage builds might be slower, I prefer that since they are self-contained. So we can accomplish the whole process or execute the whole process with a single Docker image build command instead of having to execute yarn before executing or building the images, right? So multi-stage is cool, even though it might be slower in this case. Actually, that's not completely true either. We might still need to execute a few commands, but we'll get to that part later. Let's fast forward to the end of the process that will ultimately build the image over 1 gigabyte big. If it would be a human, we would need to come up with a new term to explain it being beyond obese, like uber obese, right? If that's not how you like it, blame Backstage, not me. Okay, I will tone down mocking Backstage, poor Backstage. So let's ignore that part and just push the image. Since we are pushing it to GitHub Container Registry, it is private by default. And to make it easier to run it, we'll change it to public by opening the package settings page and changing the visibility to public. And that's it. We're done. I mean, we're not done. Now we have the image and we can run it as a container wherever we normally run applications. That could be Docker, Kubernetes, Azure Container Apps, Google Cloud Run, or almost any other service that supports containers. So let's start easy. Let's start with Docker just to confirm that it is working, and if it is, we can progress towards Kubernetes. If I wrote the instructions I'm about to execute 5 years ago, I would define Docker Compose file. However, since I don't think that Docker Compose makes sense today, we'll execute quick and dirty Docker container run. We'll publish the default Backstage port 7007 and use environment variables to run it in the development mode and to set GitHub user and token, since this version of Backstage needs it to discover catalogs and other entities from our GitHub repositories. Next is the image we just built, and finally, we'll overwrite the default command to be node package backend with appconfig YAML. That last step is important since, as we already discussed, there are 3 config files in production and one for ingress and another one for database. Right now, there is probably no need to bother setting up those, so we're limiting ourselves to upconfig YAML that is available in Backstage by default. So 1 config file for development, 3 config files for production. Now, to be clear, I'm not proud of that Docker container run command, but I did not want to spend a second more than necessary with it since we will not run Backstage like that. The goal of that command is to execute it once, only once, validate that the image works as expected, and never see it or use that command again, never again. And since we are in the validation phase, we can see that it looks okay by opening localhost 7007 in a browser. We should see Crossplane Kubernetes catalog on the home screen, thus confirming that GitHub discovery works. Similarly, if we click the create button, we should see the Crossplane Kubernetes template as well. It seems that the image with everything we explored in the previous video works. So, as I already mentioned, we will run it in Kubernetes, and that means that we can stop the container running through Docker and move somewhere else. Next, we need to define quite a few Kubernetes resources, probably in some form of templates. Now, this is the moment I will start a rant how any choice for that is better than Helm, which is the silliest and the worst option we have in Kubernetes. However, I know that many of you love Helm, you're in love with it, more than your children probably, so I won't say that Helm is the worst choice. I will keep that opinion to myself and pretend that I am also in love with it, that I like it, grudgingly. So, let's take a look at Helm templates I defined. That's a relatively simple template. It starts with a conditional that checks whether the mode value is set to production. If it is, we are deploying CMPG cluster. The alternative could be to run PostgreSQL in AWS, Azure, or Google Cloud, but today we are opting for self-managed setup, and in my opinion, cloud-native PostgreSQL is the best option we have today. If you're not familiar with it, you might want to check that video over there, somewhere there. And it's also in the description, so don't worry, you can click on it. Further on, we are creating a deployment that will result in a replica set, which will create a pod with a container that uses the image we just built. We are also setting up the environment variables that can be used to decide whether to run it in development or production mode, what the Backstage host will be, and what the database host will be as well. Database and GitHub credentials are also provided as environment variables, but loaded from secrets. Then we have ingress that enables us to open Backstage in a browser or from outside the cluster, and the service through which both ingress and internal communication will be handled. All that is pretty basic, at least for those already familiar with Kubernetes. Still, I'm very disappointed that Backstage did not provide some kind of an official chart. While it's not a big deal to create such a chart ourselves, it is reasonable to expect a project we are planning to use to have official charts and official images, even if the latter might need to be used as a base image on top of which we add additional plugins or configurations and other things, whatever other things we need. Now, before we apply that chart, we should create the namespace where Backstage will be running and the secret with the GitHub credentials. To be honest, I'm ashamed of creating the secret like that. We should have used the external secrets operator. The only reason we are not is that I felt this video is growing to be much longer than I planned, so I did not want to extend the scope beyond the absolute minimum that should get you going fast. Finally, let's take a look at the values file. Those are the values that we are likely, probably, maybe, eventually change over time. That's where we can define the mode, change the image and tag, scale the database instances, and set the ingress host. And that's it. Now we are ready to deploy Backstage to our Kubernetes cluster by executing Helm upgrade that points to the local chart directory. Initially, we'll run it in the development mode to test it out. That's probably the mode we would use locally when trying it in our laptops. Now, this might take a few moments until all the resources are operational, and we can check whether we succeeded by opening backstage. Whatever the address is in a browser. We can see that the outcome is the same as when we run it with Docker, except that it is now running in Kubernetes with all the advantages that gives us. Now, let's say that we switched our kubeconfig to point to the production cluster. Or there, we would first need to deploy cloud-native PostgreSQL chart, which installs the operator our templates use to create PostgreSQL cluster. And that's it. That was easy. And now we can execute almost identical Helm upgrade command. The only difference is that we are setting the mode to production, which, among other things, deploys CMPG cluster and instructs Backstage to use it instead of the in-memory database. Now, this will take even more time, since this time we need not only to wait for Backstage to decide to wake up, but also for CMPG cluster to be created and set up. After a while, we should be able to open it in a browser. Now, the end result is, at least visually, still the same. The difference is in what's happening behind the scenes. This time, Backstage is storing its data permanently in the database, while the previous versions would lose everything the moment we restart or upgrade Backstage pods. The chart is now ready, but we still have work to do. Among other things, we should package and publish our Backstage chart so that we can run it without having to clone the repo. But before we do that, let's uninstall it first. Packaging the chart we created is easy. We can simply execute helm package chart and we get tar file we could publish to a registry. Now, we will not do that. We will not do that at all. No, we will do that, but we will not do that manually. Instead, we'll try to automate everything so that the whole process of building image and packaging and publishing the chart is executed automatically every time we make any changes to our repository. We'll use GitHub Actions for that. If you prefer a different type of workflows, you should be able to translate what we are about to do to whichever format your pipelines expect you to use. So here we go. Here's the workflow definition I prepared. The workflow starts by checking out the repo, and after that comes my personal dedication to keep the original Backstage repo intact. It's cloned inside the source directory. Now, since I need some plugins, the pipeline executes yarn that adds them to the source directory. Since that is not enough for Backstage, some modifications must be done to the index TypeScript file. So I'm copying that file as well. That was probably the only unusual or confusing part of the workflow. The rest should be pretty uneventful and hopefully something you already did before. We are setting up a Docker container for running virtual machines using Camel. That's where the image will be built. Inside it, we are setting up a buildx, which will do the actual build, and further on, we are logging into the container image registry, which in this case is GitHub Container Registry or GHCR. With everything set up, we are building and pushing the image. To package Helm, we are first changing the version and up version in chart YAML, then executing Helm package and Helm push commands. With the Helm package created, we are publishing the chart itself. Finally, we are committing and pushing whichever changes we made back to the repo. And that's all there is to it. Add plugins and whichever other changes we want to make to Backstage, build and push the container image, package and publish the Helm chart, and push changes back to the repo. Easy, right? The only thing left is to push the changes we made locally. That will not only put whichever changes we made during the setup, but also initiate the first GitHub Actions workflow. So here it goes. Add, commit, and push. All that's left is a bit of patience. It can take a long time for underpowered GitHub Actions to build an image of the obese Backstage. The good news, eventually, later on, will be that the second run should be much faster. I will not make you stare at the screen during that hour of torture. Instead, if you're following along, you should go get a coffee and see an episode of whichever Netflix show you're currently watching. Otherwise, if you do like staring at the screen, execute gh-repo view-web and navigate to actions where you will see the workflow run. Once the run is finished, we should be able to pull the changes from the repo before we put it all together. As we already saw, the workflow is, among other things, modifying the version in chart YAML, and we can use that to get the tag we just published. With that tag at hand, we can apply the chart from the repository by executing Helm upgrade that references the OCI image with the chart we just packaged. Then we pass the version and we set mode to production. The end result should be Backstage running in your cluster. And we can confirm that by opening it in a browser. And that's more or less it. But before we part ways, please note that there is much more we should do to make it really production ready. Besides adding authentication and whichever other plugins we might be using, we should probably sync changes using Argo CD or Flux, add some policies with Caverno, switch to a managed database using Crossplane, and whatever else you might be using or you should be using today. But since I already explored those in other videos, I will avoid repeating myself here, right now. If there is something specific I should expand on, just let me know in the comments and I'll do my best. I cannot guarantee, but I will do my best to cover it. For now, all I will say is thank you for watching. See you in the next one. Cheers.